EB Wars gas experiment. We've got a KWC PT92 Taurus filled with green gas, a Umarex HK USP filled with CO2, and another KWC PT92 filled with propane. What we're going to do is test to see what the FPS and the joules are on each gun. So Troll's going to help me out here. I'm going to keep an eye on the display. According to this, 364 feet per second for the first shot at a 25 gram BB.
Ready?
Go. 232, we'll do one more. 252, alright, let's try the propane. It'll be the other KWC.
Okay.
Yep. $252. Do a little more to your side. There you go. 259.
A little more.
One more. 268. Now we'll try the CO2. $354. 354. 350. There we go. 1.05. Let's do it again. We'll do it 3 times each. Come over your way towards you a little more, because you're way off on the center of that thing. There you go. 1.27. Let's do one more, because I wasn't sure if that other one worked right. 1.03. Alright, let's try the propane. Bring your barrel over that way a little more. You're off center. There you go. 0.82. 0.74. 0.76. Now we'll try the green gas. No, dude, don't get that far back. You hit that fucker, we're dead. 0.70. 0.70. 0.72. Let's do it one more time.
So as you can see, we ran the numbers and green gas and propane seem to be consistent across the board. However, CO2 does appear to have more kick. The first shot of each gun, however, seems to deny this fact, as green gas comes out with an FPS of 364, while CO2 opens with an FPS of 354, followed in dead last by propane at 252 feet per second. However, green gas drops drastically in the next 2 shots, losing over 100 feet per second, while propane remains steady but on the rise. The second shot at 250 feet per second and the third at 268 feet per second appear to indicate that propane increases its pressure as it is used, or possibly as it stabilizes the outside temperature. Of course, this is pure speculation, as we only fired 3 shots give or take for each gun. Further investigation and experimentation would be necessary to reach a more concrete conclusion. CO2, on the other hand, stays even with the first 2 shots at 354 feet per second and the third shot at 350 feet per second. Which brings us to consider the average FPS per propellant and the range of, or differences in FPS at each shot fired. Green gas has the largest range at 132 feet per second from the highest FPS rating to the lowest. Thus, it would appear that green gas fluctuates drastically. On the other hand, propane has a range of only 16 feet per second, which appears to make it more stable. However, CO2 appears to be the most stable of all the propellants, as it has a range of only 4 feet per second. Although range is a good indicator of performance, so is average FPS, which in the case of these 3 propellants, they remain steady across the board, in that CO2 has the highest average at 353 feet per second, followed by green gas at 283 feet per second, and dead last once again is propane at 260 feet per second. However, green gas and propane are closer to each other than they are to CO2. Now that we have an understanding of the pressures that each propellant produces based on the FPS of each gun and each shot, how does this translate into terms of energy produced by the projectile on impact? In other words, what are the joules of each propellant? Surprisingly, in terms of impact energy, CO2 appears to have the largest range and the greatest impact energy, starting out at 1.05 joules, then rising to 1.27 joules, and then dropping back to 1.03 joules. However, once again, green gas and propane appear to be consistent between the two, which supports my original theory that being they are the exact same gas, they should have similar numbers. Green gas starts low and increases as it goes. The initial shot has a rating of 0.7 joules, then increases to 0.72 joules, and ends at 0.8 joules. Whereas propane seems to ride the same roller coaster as its FPS ratings, beginning high at 0.82 joules, then dropping drastically to 0.74 joules, and rising once again to 0.76 joules. Furthermore, the average energy impacts and the range of those impacts does not appear to hold the same consistency as the FPS ratings. For example, although CO2 still has the highest average at 1.12 joules, it also has the greatest impact at 0.24 joules. Whereas green gas, which had the highest range in FPS, has the middle range in joules at 0.1, and the lowest average at 0.74 joules. However, propane has the lowest range at 0.08 joules, but holds the middle ground and averages at 0.77 joules. Therefore, these test results suggest that performance is best achieved using CO2. However, green gas and propane will give similar results to each other, but not necessarily the most consistent. Thus, it would appear that one gets the best bang for their buck with CO2.